this video, I'm going to go through the basics of scientific notation. I do assume that you have some foreknowledge of scientific notation. You've used it before, you know how to use it. If you need help, by all means, come and ask me and I will help you. So here is the trouble. Physics covers everything from very, very small distances in this case to very, very large distances. So look at all those zeros in front of the atomic nucleus. And there's almost as many zeros after the 1 and the distance from the Earth to the Sun. And everything in between. Writing these longhand like this, in standard notation if you will, is time-consuming and fraught with error. Therefore, we've developed a different means of writing them that is much more compact and much less prone to error. And that is scientific notation. So how do I take and convert these numbers to scientific notation? I'm going to do 2 of them as a reminder to you. So for example, the atomic nucleus, a very, very small number. I don't know, oh, I know why it's doing that. Okay. Okay, so to convert it to scientific notation, I need to move the decimal place over. Now let's count. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have to get the decimal place moved 15 spots to the right in order to put it after the 1. Therefore, I can write this as, oh, I don't know why it's doing that. Maybe I'm pressing something. I don't know. So 1 times 10 to the minus 15 meters, where that 15 is due to those 15 spots. Now you notice here, I didn't write 1 times, because one of the properties of multiplication is that if I multiply by 1, I get the same number out. Therefore, it's not needed. On the distance from the Sun to the Earth, I have to move the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. So now my decimal place is after the 1, so I have 1.496 times 10 to the 11th, because I moved 11 spots, meters. If I do this for all the numbers in that chart, I get this. And that's a lot easier to write. A lot easier to write, which is great. Notice every number that was less than 1, or less than 0, no, try that again, less than 1, has a negative exponent because I had to move the decimal place to the right, and everything that was bigger than 1 has a positive exponent because I had to move the decimal place to the left. There's another thing we can do that makes this even simpler and prettier, if you will. And that is by bringing in the metric prefixes that hopefully you learned about in the metric prefix video. And if not, well, it's there for you to watch when you're done here, I guess. Notice the definitions. 1 nanometer, for example, is 10 to the minus 9 meters. Right, so rewriting that. 1 nanometer would be 10 to the minus 9 meters. Can I use these to rewrite those big numbers? Yeah, I sure can. So when I do that, I result in this. Femto wasn't on the list of metric prefixes, but it's 10 to the minus 15 meters by definition. So this whole thing is 1 femtometer. 10 to the minus 10 is also not on the list, but 10 to the minus 9 is. Okay, well this is 1 times 10 to the minus 10. To make it 10 to the minus 9, that's 0.1 times 10 to the minus 9, because I moved the decimal place one spot back to the left. Now this, I can take and say, hey look, that is nano. So I get 0.1 nanometers. And there it is. And I can do this with the rest of these as well.